oscillation means oscillation is a general topic. Means if my hand does like this, then it is oscillating. So if my hand is this, then it is constant. But if it does like this, then it is oscillating. So if I have a kind of a DC voltage, direct current, then voltage does not fluctuate, means it is constant. Can we make it fluctuating when it is in a controlled way, means voltage go up, down, up, down, and this continues in a kind of in a constant way or in a predictive way. So that is oscillation. So can we oscillate a voltage from a voltage that is constant? So oscillation is a topic in kind of electronics that always attracted people. It attracts it. Means how we generate a AC kind of wave or repetition kind of wave, or when or a repetition, voltage repetition, when the input is constant. So that is the concept of the oscillator. So we have already seen one oscillator in rain alarm that we have taught. So rain alarm is a kind of in rain alarm we have a capacitor. So a capacitor initially it charges from the DC voltage and it is connected to base and base of an emitter, base of a NPN transistor. When voltage grows up to a level, that NPN transistor becomes active. When it becomes active, its base emitter, the diode, so that start kind of, so voltage regulation happens, and the reactance or the resistance, it tends to become zero. So capacitor first it charges from the voltage source, and then it finds that there is a path to discharge, and it discharges. It discharges to a level the transistor become inactive and it become off. So this can be seen in our videos, and then capacitor charges again. So oscillation in electronic circuit typically, if there is an electronic component like capacitor, if it charges and discharges through different paths, charging path is different, discharging path is different, then typically it leads to oscillation. So this is what we have seen. But the charging and discharging directly or indirectly, it should be tied to the device only. So here capacitor is taking help of a transistor to get charged and discharged, but it is directed through the capacitor. Okay, so in the series of oscillation, the way I said oscillation is a topic that always attracted people in electronics. So now we'll see one more scenario where if I have a capacitor and I charge the capacitor, okay, so capacitor is charged. Now capacitor has to discharge, so charge and path and discharge path will be different. So capacitor is discharging to an inductor. So inductor is connected to capacitor. So first capacitor is charging, then charge path is disconnected and capacitor is connected to the inductor. And inductor is charged from the capacitor. Because of inertia, capacitor loses all its energy and it comes to inductor. So capacitor discharged through inductor. Now inductor again charge back the capacitor because it's a closed loop, but charge will happen in opposite direction. Now capacitor get charged, then again it will charge back the inductor, okay, in opposite direction, and then inductor again charge back the capacitor in the direction what it initially get charged through the battery. Okay, so charging and discharging is happening through the inductor. So this we called it a LC circuit, but the story is that capacitor cannot depend upon the inductor, because if capacitor charges the inductor in a closed loop, if I have a capacitor and inductor connected to each other, then if one is charged, then it charges other. Since one loses the charge, then other charges it back in opposite direction. Then it charges back that in opposite direction. Then in opposite direction it charges it back. But capacitor is losing the energy. Means whole circuit is losing the energy. So capacitor more or less it is discharging to the inductor. Okay, so capacitor is discharging to the inductor, then capacitor should get back the charge from the other path. This is a kind of something that we are seeing differently. Okay, so in previous circuit, capacitor was charged from the battery, discharges through the base emitter junction of the transistor, and then charges back from the battery. Same thing we'll see here. Okay, little convoluted way. So if I in a circuit, I have only two entities, capacitor and inductor. We are talking about Colpitts oscillator. Okay, so in a loop, if I have a capacitor and inductor, capacitor is connected to inductor. I can say in series or I can say in parallel. Doesn't matter. It is connected back to back. And capacitor is initial phase. It is charged. If capacitor is charged from one path, it does discharge it to the inductor. Okay, inductor again charge back the capacitor in opposite pole, and then capacitor, since it receives the charge, then it charges back the inductor. Now inductor again charges back the capacitor in the first pole, the way the battery had charged. So it gets repeated. But this is not the end of the story that oscillation will start happening. Because oscillation will happen only when if someone is charging and discharging through other paths. So capacitor, consider inductor as a discharging circuit. It discharges, okay, it gets back and it leads to an oscillation. That is a different story. But it sees the inductor as a discharging circuit. So when capacitor discharges to inductor repeatedly, means as it starts oscillating, so repeatedly it should get back the charge from the battery source. So since battery source is DC, and here the story started happening in a charge-discharge fashion, so we expect kind of a circuit which would charge the capacitor in the equal phase of the way it is charged. So this is one story. So capacitor and inductor LC circuit, they are connected in a fashion that they repeat energy transfer to each other and it starts oscillating. Once it starts oscillating, but they lose energy because of the internal resistance of the circuit. And then finally, immediately it will come to zero. So the frequency at which the charge and discharge happens of the capacitor should get back the charge. So I would say the frequency at which the capacitor is discharged. So capacitor should get back the charge at the same frequency. So that it cannot get back from the battery because the battery is a DC. So capacitor would get back. So we kind of think about a circuit like an external circuit which would feed a voltage to the capacitor in the equal frequency. So that we'll see like an amplifier, transistor based amplifier which receives the minute input from the capacitor, it amplifies it, and in the same phase, the way capacitor was charging. So capacitor, if there is a capacitor and this is positive, then when positive is getting charged at that moment, so in equal phase, it should get back the charge. So in the earlier circuit, it was okay with the DC source, but here it is not okay from the DC source because internally capacitor is charging through the inductor, and that generates the oscillation. But as per the oscillation, capacitor should get back the charging. So inductor is considered a discharging circuit, and capacitor should be charged from the external source. So how this happens, charging and discharging through the external source, so that we'll see. So capacitor we divide into two parts, and two capacitor, and one capacitor kind of feed to the amplifier, then amplifier amplifies the signal and feedback to the other capacitor in the voltage divider, and that capacitor somehow, the way it happens, somehow it gets back the voltage in the phase. So because generally a transistor amplifier, it does the 180-degree phase shift. Again, it comes back to other capacitor, then it becomes 360 degree. This is one story. Another story, so this is about a capacitor charging and discharging. So capacitor is discharging through inductor, and capacitor, the way it is oscillating, so that oscillation frequency is passed to amplifier and it getting charged from amplifier. So amplifier charging capacitor. Capacitor is discharging to the inductor, LC circuit somehow it makes it oscillate. So this is one part of the story. What would be the frequency of the oscillation? We will see many kind of oscillator. So, but everyone has same charge and discharge, and then the electronic component which is charging and discharging, it should control the charging and discharging. So that is this. Like here capacitor is controlling the charging and discharging. So first it is discharging through inductor, and then whatever the oscillation is happening, it is giving to amplifier and amplifier. So capacitor is controlling everything. Now, what is the frequency of the oscillation? So that is another story. So generally, a capacitor when it charges and discharges, if frequency is high, then capacitor generally it tends to provide less resistance, whereas inductor tends to provide more resistance. Means if we see kind of electronics world, so electronics world is a story of resistance, and it is not a story of phase shift, and it is not a story of phase shift and reactance and capacitance. So battery sees the net resistance in ohm. So resistance always in ohm, not in the phase shift and 90 degree and 180 degree. So battery sees, or the voltage source sees the resistance, and based upon the resistance, it emits the current. So that is the scenario. So how much would be the frequency? So capacitor is a guy which lowers its resistance when frequency grows, and inductor does the opposite way. So what would be the frequency? So there will be many graphs and this and that. But in electronics world, if an entity is radiating energy, then entity which is receiving the energy, both should be at same frequency, same resistance level. So if this guy is emitting energy and this guy is receiving energy, at middle point, okay, the wave looks back the source. What is the resistance? So this is called kind of the output resistance, and then wave sees where it is going. What is its input resistance? Okay, so this is source, this is destination. Okay, so wave or current is passing from source to destination. At one point, it sees back what is the resistance and sees front what is the resistance, and both should be same for the maximum amount of the transmission. So in the capacitance and inductor, if they show equal reactance, equal impedance, equal resistance, then the energy flow will be maximum. So resistance showed by capacitor is directly inversely proportional to the frequency, and resistance showed by the inductor directly proportional to the frequency. So it will come to a level where the reactance would be same, that frequency it will oscillate. Okay, so we will see kind of one peculiar way where anyway we have seen in rain LR that the capacitor charges and discharges through different paths, and it oscillates. And here it will, so discharging path is through diode, through the transistor's base emitter junction, and charging is through DC. But here discharging is through inductor, and charging is from a amplifier, and that is controlled by the capacitor. So that Colpitts oscillator. So that means